Myself Varshini BB. I am studying in Sri Venkateshwara College of Engineering, first year. Today's my topic is optical fibers and its types. What are optical fibers? Optical fiber is a flexible glass that can transmit the light from one end to other. Such fibers find wide usage in fiber optic communications where they permit transmission over longer distances from and at higher bandwidths than electrical cables. Fibers that support many propagation paths or transverse models are called multimode fibers, while those that support a single mode are called single mode fibers. Multi-mode fibers are generally have a wider core diameter and are used for short distance communication links and more applications where high power must be transmitted. Single mode fibers are used for most communication links longer than 1050 meters. There are three types of optical fibers. As we know, first one, step index single mode fibers, step index multimode fibers, granted index multimode fibers. Let us discuss about the first one, step index multimode fibers. These fibers with a core diameter less than about 10 times the wavelength, the propagating light cannot be modeled using geometric options. Instead, it must be analyzed as an electromagnetic waveguide structure according to the Maxwell's equations as reduced to the electromagnetic wave equation. As an optical waveguide, the fiber supports one or more confined transverse modes by which light is propagated along the fiber. Fiber supporting has one mode is known as single mode fibers. The waveguide analysis shows that the light energy in the fiber is not completely confined in the core. The most common type of single mode fibers has a core diameter of 8 to 10 micrometers and is designed for use in a near infrared. Multimode fibers by comparison is manufactured with core diameters as small as 50 micrometers and large as 100 of micrometers. You know, second step index multimode fibers. Fiber with large core diameter that is greater than 10 micrometers may be analyzed by geometric optics. Such fibers is called as multimode fibers from electromagnetic wave analysis. In a step index multimode fibers, rays of light are guided along the fiber core by total internal reflection. Rays that meet the core cladding boundary at an angle of greater than critical angle for this boundary are completely reflected. The critical angle is determined by the difference in the index of refraction between the core and cladding materials. The critical angle determines the accepting angle of the fiber, often reported as a numerical aperture. A high numerical aperture allows light to propagate down the fiber in rays both close to the axis and at various angles, allowing efficient coupling of light into the fiber. This high numerical aperture increases the amount of dispersion of rays at different angles, have different path lengths, and therefore take different amount of transfers the fiber. Last one, granted index model fibers. The index in refraction is the core decreases continuously between the axis and the cladding. This causes light rays to bend smoothly as they approach the cladding rather than reflecting from the core cladding boundary. The result curved paths reduce multi-path dispersion because high angle rays pass more through the lower boundary rather than the higher index end. The index profile is chosen to minimize the difference in axial propagation speeds of the various rays in the fiber. This ideal index profile is very close to the parabolic relationship between the index and the distance from the axis. Thank you for watching my video.